Okay, so this is a key to Quiz 2 version 1, and the direction says solve each equation, show all work as presented in class, so you hit to show all work to receive full credit. Make sure all statements are mathematically correct. Alright, so this is a radical equation, and in this particular radical equation you are looking at square root. So the index is 2, so square root. Whenever solving a radical equation, you need to get the radical by itself, and it is in this case. The radical is already by itself. Once you get the radical by itself, the next idea is this. I'm going to go ahead and rewrite this over. So the approach to solving a radical equation is to raise both sides to a power equal to the index. So the index here is 2, so I'm going to square both sides. Now on the left side, you have a binomial squared, so remember that means x minus 2 times x minus 2. On the right side, when I simplify this, the square root of 16 minus 3x times the square root of 16 minus 3x is just the radicand. So remember the square root and the square are inverses, so they undo each other, so you get 16 minus 3x. Alright, so I'm going to go ahead and multiply this out using FOIL. So x times x is x squared. The outer is a negative 2x. The inner is also a negative 2x. And the last, a negative 2 times a negative 2 is a positive 4, equal 16 minus 3x. Combining like terms, now notice I went from a radical equation to a quadratic equation. So this is quadratic equation because the largest exponent is 2. Alright, so combining like terms, I get x squared, a negative 2x and a negative 2x, and negative 4x plus 4 equals 16 minus 3x. Adding, so I'm going to go ahead and bring all the variables to one side. So I'm going to go ahead and put this quadratic equation in standard form. So I'm going to get 0 over here. So I'm going to add 3x to both sides, and notice I'm going to go ahead and line my like terms. What you do to one side, you do the other. When you combine your like terms, you get x squared minus x, negative 4x plus 3x is a negative x, plus 4 equal, and then this, when you combine, gets 0, so you get 16 here. Subtracting 16 from both sides. Combining like terms again, I get x squared minus x minus 12 equal 0. All right, now at this point, you want to solve this quadratic equation. So in this particular case, it is factorable. If you couldn't factor it, you'd go ahead and use the quadratic formula. But this is factorable, so I'm going to go ahead and factor this. So I get x, and then I need a negative 12, and the middle term has to be negative. So that's going to be a negative 4 and a positive 3. And so when I solve this quadratic equation, I'm going to set each factor equal to 0, so the 0 factor property. And so I get, I get this. And then solving each linear equation, I get x to be 4 and x to be negative 3. Now remember, these two values here, this is a solution to this equation, this is a solution to this equation. They are both solutions to the quadratic equation. So I'm going to call this proposed solutions. Alright, so these are proposed solutions to the quadratic equation, to the radical equation. Now they're proposed solutions because you remember in a previous lesson, whenever you have a radical equation and the index is even, you're going to raise both sides to an even power. When you raise both sides to an even power, you tend to introduce extraneous roots. So you got to check and see if these proposed solutions, if any of them are extraneous roots, which means that they're not going to be solutions to the original. All right, so you have to check. So let's go ahead and check x equal 4. All right, you go back to the original, which is this. Go ahead and rewrite it. So you get x minus 2 equal the square root of 16 minus 3x. So where we see the variable x, you're going to substitute 4. So you get 4 minus 2, and we see that's going to equal 16 minus 3 times 4. That's a 3 here. So 4 minus 2 is 2. And again, I want to see that's going to equal the right side. 3 times 4 is 12. So I get 16 minus 12, which is the square root of 4. And the square root of 4 is 2, and they are equal. So far 4 is a solution. I'm going to put 4 as a solution. Now let's check x equal negative 3. I again, go back to the original, which is this. And where we see the variable x, you're going to substitute negative 3. So I get negative 3 minus 2. And I want to see that's going to equal the square root of 16 minus 3 times negative 3. A negative 3 minus 2 is a negative 5. And over here, I have 16. A negative 3 times a negative 3 is a positive 9. So that is the square root of 25, which is positive 5. Notice this side's positive 5, this side's negative 5. So this is going to be an extraneous root. So it's a solution to the quadratic equation, but it's not a solution to the radical equation. So the only solution to number 1 is 4. So you had to show all this, though. You had to indicate that this was extraneous. You had to show that you did check for extraneous roots. That was all part of the deal right here. Okay, number 2, you have the absolute value equation. Now, when solving an absolute value equation, just like you did the radical, you got to get the radical by itself here. Same thing here, you got the absolute value by itself. So I'm going to subtract 2 from both sides. So I get the absolute value of 3x minus 5 is equal to 6. Now, once you get that point where you have the absolute value and you had to show this part, then you're going to split it down to 2 equations. And the 2 equations are going to become, remember, this stays 3x minus 5. This stays 3x minus 5, and the value on the right side will be 6 and the opposite of 6, because that's the relationship between what we mean by absolute value, which is the distance that the number is from 0. So 6, negative 6. Alright, now notice I went from an absolute value equation to 2 linear equations. I just solved those linear equations. I'm going to add 5 to both sides. So I get 3x equal 11. To get x by itself, I divide both sides by 3. And so I get x to be 11 thirds. So that's one of my solutions. Now, with absolute value, you don't have to check these. You can if you want to, but you don't have to check. You have to check whenever you raise both sides to even power, though. Okay, adding 5 here, I get 3x equal negative 1. Divide both sides by 3. My other solution is negative 1 third. All right, so my solutions are 11 thirds and then negative 1 third. Those are your solutions. Okay, so that's going to take care of the key to quiz 2 version 1.